prefix and suffix, and you will get your full name. Okay, how we can synthesize alkynes? We can synthesize them by using vicinal dihalides as a reactants, right? Vicinal mean adjacent. Vicinal is a word that we use for adjacent, and di mean two, halides mean halogens. So we will choose the alkyl halides that will have two halogens, right? Two halogen atoms attached with the carbon chain. But what we have to do, we have to d mean remove, hydro mean hydrogen, halogen mean halogen. We have to remove hydrogen and halogen from the adjacent carbon atoms. But we are talking about vicinal dihalides. In case of alkenes, we have chosen just alkyl halides, but here we need dihalides, right? But we have to remove hydrogen and halogen from the adjacent carbon atom, just like we did in case of your alkenes. So you can see this is a compound, this is an alkene containing 1 and second X is the indication for the presence of your halogen. The general representation of halogen is basically X. It could be your chlorine, bromine, or even iodine. Okay, now you can see these are X and X, they are on the adjacent carbon atoms. That's why we use the term vicinal, but they are 2 in number, so dihalides, right? Vicinal mean adjacent, di mean 2, halides mean halogen. So they are basically alkyl halides, but they are dihalides, right? Now what we have to do, we have to treat them with alcohol, just like we did in case of alkenes, but there we were just available with just alkyl halide, one alkyl halide, monohalide, right? Now we have two halides here, so that's why we are going to remove them one by one, but with combinations like that. You can remove hydrogen from this carbon. If you are going to remove hydrogen from this carbon, then remove the halogen from the adjacent one. They should be removed from the adjacent carbon atoms. Now if you don't want to remove that, then remove hydrogen of this carbon and remove the halogen of this carbon. They should be on the adjacent carbon atoms. So if you remove this combination, the second one, H and X, now you are going to get a double bond here, but again you can see we have another combination, H and X. Okay, this dashes, they could be hydrogen, they could be carbon, depends on you, whatever suits you. Okay, H and X. Now you can see X halogens are good leaving groups. They can easily get separated from the reaction mixture or from the reactants, so we can remove the same thing in the second step, right? Now we are going to remove the second pair of HX, so they will give you a second double bond, right? So they are vinyl halides. Vinyl is basically C double bond C and a chain of carbon, right? Okay, there are two things. We are going to treat this compound with KOH and they will give you a triple bond. What is going to happen? We have what we did in case of alkenes. We were just available with one HNX. We just removed that and we got a double bond. But here we have two leaving groups, so remove them one by one. In every step you will get a bond. If you remove first pair, you will get a double bond. If you remove second pair, you will get a triple bond, and this is your alkynes. So this is the method in which we remove hydrogen and halogen, mean dehydrohalogenation of what? Vicinal dihalides. If you want to synthesize alkynes, choose vicinal dihalides as a reactant. If you want to synthesize your alkenes, you have to choose alkyl halide with monohalide group on them, right? Okay, now we have to learn about the second method. We are going to remove halogens. In the previous slide, we have removed hydrogen and halogen, but here we are going to remove halogens, right? From what? From tetrahalides. Tetra mean 4, halides mean halogen. So your halide, 4 halides will be attached with what? With your respective carbon chain. So I have chosen a 2 carbon chain, that is ethane, right? And every single carbon atom is having 2 halogen atoms. In this time the halogen is bromine, right? And we are going to remove halogen. D mean remover, halogen mean halogen. So we know that if we want to remove something, we have to remove that from the adjacent carbon atoms. So you can remove this one bromine or the combination this one. You can remove the combination of this one bromine or this one, the choice is yours. I'm going to remove this one, right? The bromines that are on adjacent carbon atoms, right? So I'm going to remove that, but we have to use zinc as a catalyst. So as a result, you will see we will get a double bond. By the removal, first removal will give you first double bond, and your second product will be zinc bromide. Zinc will take 2 bromines, so ZnBr2. Now you can see we have another leaving group available here. So we have to remove it, and we have to perform the same reaction in the second step. For that purpose, choose the zinc or use the zinc again, right? And it will give you this time a triple bond, and the side product will be zinc bromide, right? So zinc is used as a catalyst. It helps to remove halides from the alkyl chain, but halides should be removed from the adjacent carbon atom. First removal in the first step will give you alkene. In the second step, you will get alkyne. Is that clear? So you have to do these type of reactions in 2 steps. These were 2 preparatory methods for your alkenes. Let me discuss about the properties of alkynes. First of all, by their nature, they are non-polar in nature. Every 3 classes of hydrocarbons, alkanes, alkenes, alkynes, are non-polar. Just because they are made up of carbon and hydrogen, they have very small difference of electronegativity